Okay, guys, if we can take your seats, thank you. So, good morning, everyone. How are we all doing? We're enjoying the first event so far, the Alumni Awards, and now welcome now to the inaugural 3MT research event in Ideas 2024. So, does anyone know what 3MT is? I'm sure you do, that's why you're here, right? Okay. So, before I do that, let me introduce myself actually. So I'm Jason Amatori, I'm part of the Biomedical Engineering program here at MSFEA. And the 3MT or 3-minute thesis presentation event is where students need to present their slides, or present their research I should say, in only 3 minutes using one slide. Okay? So they can't dance, they can't sing, they can't do backflips on stage, even though that would be quite impressive. Not allowed. They're to be able to, well, the aim is to be able to give you insights into their research, their topic, what they've done, what they're going to do in the simplest way possible to a non-expert audience. Okay, that's what it's really about. Now, I'm not sure if you've been following 3MT through the years as we're hosting it through Ideas, but in case you're not aware, 3MT was first introduced in 2008 by Australia, in an Australian university known as the University of Queensland, and since been expanded to the rest of the world. Now, because of its Australian foundation, we've kind of been giving this session a bit of an Aussie theme. So, firstly, with yours truly, originally from Australia, but secondly, last year I started introducing a bit of slang, Aussie slang into the event to educate you in case you go to Australia and you really want to fit in. So how many of you were here last year? Oh, good. So, I'm going to test your knowledge to see if you still remember what we learnt from 2023. Does anyone want to yell out any of those slang words they remember? Taka, good. What's taka mean? Food. Well done. Well done. Any others? Oh, we can't. Mate. Yeah, mate. Yeah, so little man, Habib, whatever you want to refer to it as. That's it. There's a couple of nice ones. Tucker's a good one, but here we go. We'll just go through them. So we had mate, which was like friend or man. G'day, which was good day. That's a typical one, right? G'day, mate. Fair dinkum was the interesting one. Anyone know what fair dinkum means? Genuine, like saraha, I guess. Yes, it's spelling genuine. Arvo means afternoon, and taka means food indeed. So they're 5 words. We're going to learn a few more today, okay? Then you're going to have 10. You'll have a really nice arsenal to fit into the Aussie crowd. So the first one, I've got true blue. Anyone want to hazard a guess? No? Okay. True blue? Doesn't mean you're truly blue. You're cool? Well, no, not really. So it means that you're patriotic. So you're a true blue Aussie or you're a true blue Lebanese, okay? Ankle biter. Ankle biter, American. Ankle biter. No takers? Annoying? No. But close. They are generally annoying sometimes. No. So ankle biter, but you're on the same level, they're small, it's a baby or a child, okay? I guess because they crawl and they bite your ankles or something, I'm not sure where that came from. Bludger. Crazy? Well done. So bludger actually means lazy. So look at this bludger over here. Look at this guy bludging, watching TV instead of doing his professor's homework, right? Okay. Buggered? No? No? Any other takers? Buggered? I mean, I'm exhausted. I'm tired. I'm buggered. I can't do my work, okay? I use that one a lot, actually. So, ripper, final one. Well, some of you have been to Australia, must have heard these before. Ripper. Great? No? No other guesses? So it's like fantastic. You ripper, or that's fantastic, or that... whatever you want to say. So 5 more words that you've gained into your vocabulary. I'm going to be testing again in 2025 if we're all still here. So study hard and we'll see how we go. Okay, so back to the main event. So this event does have awards tied to it. The first one is formally judged using set scoring criteria by MSFEA volunteers. Okay. The second one, which is probably of more interest to you guys, is the People's Choice Award. So you, the audience, are going to choose who the best presentation was. So as you go through the session, and make sure you stay throughout the whole session, do always note down who you found was best, or at least your top 2 or top 3. Then wait till the end when I give you instructions on how you can vote and choose the best one that you liked. Cool? Okay. So we have 12 speakers today coming from all different departments within the faculty. So you're going to be hit really quick with a lot of great research that we're doing at the moment within MSFEA. So it's going to be a really nice experience. I'm sure you're going to enjoy it. So we're going to start off with our first speaker, who is Ali Tayyar, Dendritic Growth, Unveiling the Dark Side of Batteries. So Ali, if you want to come up.
So, have you ever found yourself in a place where your phone dies at the worst possible moment? Maybe you were lost in a new city, or about to take the perfect picture, or in an important phone call with your boss. Well, it always seems to happen when you need it the most, right? So, how can we improve rechargeable batteries so you don't have to deal with that frustration again? A rechargeable battery works in a way where the ions from the upper side of the battery, which is called the anode, move to the lower side of the battery, which is called the cathode. Well, when these ions touch the lower side of the battery, they start stacking on each other, and that's the enemy. So this stacking creates a tree-like shape, or what we can call a dendrite. Unfortunately, when these dendrites grow, they start touching the upper side of the battery, causing what's called a short circuit. This short circuit will, or in other words, it will simply get damaged. Thus, this Tesla car, which mainly uses lithium batteries in its charging, will catch on fire. My research focus in the past 2 years was on how can we improve rechargeable batteries and minimize this dendritic growth. Eventually, we found it to be achievable through an innovative, simple solution by simply changing the shape of the cathode and the anode and bending them. We intended to do that by having the battery as 2 circular circles, having them concentric, where the ions will move from the outer circle to the inner circle. We tested the proposed solution, and we found that the tested circular battery is better than the regular battery, which means it can handle more ions than the regular battery without short-circuiting. And that's simply because an ion in a circular configuration have more safe space to pass through while making its way to the other side. Thankfully, this research might help in increasing safety measures in appliances like electric vehicles, electronics, phones, and more in the upcoming years. This paper, or this research, was published in Physical Review e-journal, and thankfully, I was the youngest student in the faculty to co-author a scientific paper in my second year in undergraduate studies. Thank you.
Okay, thank you, Ali. Very nice. So our next speaker is going to be Jana Schmeisem, Magnetized Concrete, the Green Building Game Changer. So Jana, if you'd like to come to the stage.
Hello, everyone. Now, first, let's think about the air we breathe. Did you know that about 13% of global CO2 emissions stems from industries like cement productions? Yes, you heard that right. Concrete, which is all around us in buildings, roads, and infrastructures, contains a leading source of CO2 emissions. And cement is one of the main components of this concrete. Now, without sustainable alternative, we risk accelerating climate change, risking human health and many other negative consequences. But fret not, because today we're delving into an exciting realm where science meets sustainability. My research is about investigating how magnets and titanium dioxide nanocapsule both can boost concrete strength while reducing cement content. Now, for a sustainable alternative, there's often a price paid, like sacrificing strength, which is one of the main properties of concrete. However, our finding challenged its norm as we aim to potentially boost concrete strength while making it more eco-friendly. We need to reduce the cement content. And why do we need that? Because reducing cement contents mean we're reducing our carbon footprints. That's actually coming from the production process, which is a great news for environment and can change our game. Now let's dive into the science a bit. We all know that magnets have these invisible force that attracts and repel things away. Now, we're going to use these magnetic force to interact with the concrete molecules. It's like giving our concrete a secret power boost. But why the addition of titanium dioxide nanocapsules then? Like, isn't magnesium more than enough? Actually, these nanocapsules are the superheroes here. They are known through past research for enhancing material properties. But what's the adventure in our case? The thing is that they're metallic in nature, which means they react better to magnetic forces when they're encountered to. And there's even more. Titanium dioxide also excel in microstructure healing, which is accelerating or self-repairing of these tiny little cracks that form within the concrete that decreases its strength and its lifetime. The future of our buildings is to make it more strong and sturdy, making it more economic and enhancing its lifetime, resources, and make it less economical. My research is the first of its kind, aiming to potentially enhance the future of construction and building. The future of our building, it's not about just building tall. It's about building strong, smart, and green. Thank you.
Moving on, now we have Sara Sayah, muscling up the upper airway to restore sleep. So Sara, would you like to come up?
Hello, everyone. First, I'd like to introduce you to David. Ever since he's gotten married 5 years ago, he's managed, without fail, to wake his wife Sophia up several times an hour every single night to allow an alarming snoring noise. David, like millions of people around the world, suffers from obstructive sleep apnea, which is a sleep disorder where the muscles in the upper airway relax during sleep. Muscles such as the tongue fall into the throat, causing the airway to collapse and blocking air from entering and reaching the lungs. As you can imagine, people suffering from this disorder are at an increased risk of serious complications, such as heart attack and even stroke. One possible treatment for obstructive sleep apnea is hypoglossal nerve stimulation, where an implanted device electrically stimulates the hypoglossal nerve, which innervates the tongue muscle, causing the tongue to contract and move outwards, opening the airway and allowing air to enter. Unfortunately, though, this treatment doesn't work for everyone, which is why I have dedicated my thesis to researching possible ways to improve hypoglossal nerve stimulation treatment outcome and help more people, such as David, suffering from obstructive sleep apnea. If you've ever attempted lifting a weight too heavy for you in the gym, you know how difficult it is to do so without a little help from someone else, such as the trainer. This same logic might actually apply to the upper airway muscles. Sometimes it may be possible that the tongue needs a little help from a nearby muscle located just beneath it, the geniohyoid muscle, to be able to open up the airway and stop it from collapsing so the air can continue to enter to the lungs. Unfortunately, though, not much research has been done to see how stimulating the geniohyoid muscle in combination with the tongue muscle can improve treatment outcome. So, by using a previously validated computational finite element model of the upper airway, I was able to obtain results indicating that stimulating the geniohyoid muscle in combination with the tongue muscle was almost twice as effective in opening up the airway and increasing its area, therefore preventing its collapse, as compared to stimulating the tongue muscle alone, which is usually done in conventional treatment. These findings have great potential to improve hypoglossal nerve stimulation treatment outcomes and help more people, such as David, by restoring sleep to him, and also to those suffering along with those affected by obstructive sleep apnea, such as his poor wife, Sophia. Thank you.
Great, thank you so much, Sara. So now we've got Leah Sakhr talking to us about hybrid transport. So Leah, come on.
Okay, so imagine standing at the crossroads of land, sea, and sky. Now imagine that these crossroads aren't just spaces you go through, but rather an experience in itself. That's the world we're diving into today. I introduced to you the hybrid multimodal terminal. Let's start by acknowledging the reality of the generic and distinct nature of these terminals. These spaces lack a discernible identity or a unique architectural language. Traditionally, terminals have been assigned the term non-spaces, which means areas of transit and anonymity, lacking identity and connection. However, the research that has been done has revealed a method to turn these non-places into places, environments that have character, that are destinations and provide an experience. Therefore, within this challenge lies an opportunity to do so. This is the aim of the thesis. Let's break it down. So the method of challenging this typology is threefold. Firstly, it's about rethinking the very concept of terminals. It's about connecting seamlessly, taking you from one place to another while also providing an experience. Ports are more than just a point of departure. They are the physical embodiment connecting between different realms. So let's think of them as the intersection between the aerial, the terrestrial, and the aquatic. It's the place where they meet. It's a limbo of being between two places and two time zones at once. Therefore, by hybridizing these traditionally separate entities, we can unlock a multitude of typological possibilities. It's a hybrid typological model that acts as an airport, a seaport, and a bus terminal, a ferry terminal all in one. Secondly, we can think of the travel experience as a whole and try to bring it into the architecture of the building within itself. When we think about going into an airport per se, one goes through a series of experiences, a series and steps in order to reach the airside. So let's think of it as a factorial pipeline, and architecturally, this translates into paths and nodes that can be manipulated and elevated in order to fit in a certain program and inform the architectural layout. And this architectural layout can be manipulated by other factors that we can consider, such as speed and time of each function, that can help shape the building that we are making. And this point goes beyond just taking into consideration the user experience, but rather the experience within itself, in order to provide a hybrid terminal space that is efficient in terms of flows. And lastly, we can contextualize and tailor our approach by considering the location and significance of each terminal site, whether it's cultural or historical heritage of the country or the strategies that are important to the location. We can integrate these contextual elements in order to further inform our design. Therefore, we can use these four methods of hybridization, experiential thinking, and contextualization in order to challenge and redefine terminal spaces into places.
Great, thank you, Leah. So we're moving on to speaker number 5, who's Asad Eid, energy harvesting from 5G.
Hello everyone, I'm Asad Eid, and today I'm here to prove that tough times can inspire amazing ideas. 2 years ago, I was an undergrad here at AUB, and there was the pandemic, so we were attending classes online from home. If you remember, during the pandemic, Lebanon faced a fuel crisis. So one day I had an exam, and I woke up to no electricity and no generator. To make things worse, I had forgotten to charge my laptop. So I started yelling and shouting as a normal Lebanese people. So my sister came and told me, aren't you an electrical engineer? Then go find a solution. Today, I'm here with a solution. Billions of IoT devices around us need power to function, especially sensors. By 2026, these devices will surround us. This is the promise of the Internet of Things, IoT. Now, billions of devices means billions of batteries to be continuously replaced and discarded, which will pose a significant threat to the environment. Now, what if we have a sustainable way to charge these devices? If we look around us, we will find a lot of waves and signals that are primarily used for communication. Why don't we capture these signals and use them beside communication as a power source, so we can charge our devices from signals? So this is the concept of energy harvesting from 5G. Now, moving from a concept to the real implementation, I started by designing an antenna to capture these signals. So I designed an array of 8 antennas. Each antenna is placed using a new method new novel method that will maximize the signal reception. Then I designed a network with 8 ports to capture these signals and sum them up and send them to the rectifier. Then the rectifier, we have the rectifier. Its job is to transform these 5G signals into DC power so we can use them to charge our devices. Now, to sum it up, I want from you to take your phones, go to Settings, then Wi-Fi. You will find the on-off button. Now, this button serves to connect you to Wi-Fi. With my project, we have the ability, instead of only connecting to Wi-Fi, turning on this button will help our phone to continuously charge without the need of adapters and cables. This is how I turned my problem into an idea, and the idea to reality. Thank you.
On the alarm bell. Thank you very much, Assad. So we've gone to the halfway point, or nearly actually. We've got Sahara next, so maybe we'll do Sahara first. Okay, so Sahara Salah, mapping seizures with flexible bioresorbable arrays.
Our brain is what makes us who we are. If anything were to go wrong with it, we would just stop being ourselves. Some people live with the constant fear of their brains just going haywire at any time. These are the people with epilepsy, the most common neurological disease, in which the brain, in simple words, goes into overdrive. Epilepsy causes seizures, in which you lose consciousness and you have uncontrollable shaking and jittering. Kids as young as the age of 5 may be diagnosed with this debilitating disease. Now, in most cases, epilepsy can be managed through medication. However, when medication proves to be ineffective, surgery becomes inevitable. In this surgery, the doctors remove the part of the brain that is causing this abnormal electrical activity. This is why it is crucial for us to pinpoint the exact location of this part with high accuracy. And this is where our innovation steps up. We developed a device that is implanted on the surface of the brain and records its electrical activity with high resolution. What sets our device apart is, first, its ultra flexibility, which allows it to seamlessly integrate with the brain's soft material. You can appreciate the intimate contact this device makes with the brain of a rat in this case, where it looks as if it's tattooed onto the brain. The second and more important feature is that our device is fully biodegradable, meaning that once it's implanted in the body, after a certain period of time, it simply disappears. Now, to put our invention to the test, we recorded the brain activity of a rat in 2 cases, normal versus epileptic. And this is what we saw. For the normal brain, the rat showed typical low activity, while during epilepsy, this activity intensified and even the shape of the signal changed. With several electrodes mapping out the surface of the brain, we translated these electrical signals into an image where high activity translated to red color and low activity to blue. As a result, we were able to visualize the areas of the brain that had the highest epileptic episodes. With our innovation, detecting seizures in the brain is no longer like looking for a needle in a haystack. It is now more like navigating a map. Thank you for listening.
Okay, thank you very much, Sahara. So I thought we'd have a really quick break, okay? We've gone through some 6 talks at the moment. The brain starts to lose attention. I want you to be aware and awake. We'll give our judges a chance to actually collate their scores. So just in this minute, while you're breaking away from the talks, I thought to tell you about some more stuff about Australia. I'm not biased at all, am I? Look, so it's not just 3MT, and of course myself, right? There are other great things that have come out of Australia. Yeah, what do you think they are? I'm going to surprise you, probably. I think you'd agree. Wolverine, Hugh Jackman's one of them. Margot Robbie, Barbie, I think, these days. Thor, Chris Hemsworth, and his other brother too. So, yes, a lot of actors have come out of Australia, but in all seriousness, there's been a lot of inventions out of this country I think that you're not aware of. So the fridge initially came out of Australia. The flight recorder in the aeroplanes, when they go down, doesn't get damaged. They can retrieve information. These inflatable ramps, if you're ever in an emergency, an Australian invention. And look, you can thank Australia for your Wi-Fi at home as well, okay? The electric drill, cordless electric drill, and also some amazing medical innovations. For such a it's a large country with a low population, we do make some breakthroughs. So ultrasound, originally from Australia, the cardiac pacemaker to keep the heart beating, the cochlear implant, so I can hear, and also the CPAP machine. If you want to know what that does, you have to come tomorrow to the Ideas Talks, okay? So lots of stuff out there. I could go on and on. You can thank me personally for these later if you like. I'll take those. I'll send them across, okay? All right. I think we're ready to go on. So have yourself a bit of a stretch, though. Stretch your brain. And unfortunately, our seventh speaker couldn't be here, so we'll move on to number 8. So Zainab Kanafir, can building shafts enhance urban street canyon passive ventilation? So come up, Zainab.
Picture with me Hong Kong in China, Delhi in India, or even Beirut here in Lebanon. I'm pretty sure you've always looked at such places and said to yourself, wow, whether at the way they are well organized or not, both work. But have you ever thought of how they might be affecting our only habitual planet to this date, the Earth? Although these cities offer quite a variety of services and comfortable lifestyles for their citizens, they also contribute to the rise in air pollution. In fact, studies have shown that densely populated areas have been continuously struggling with low air quality and ventilation problems, impacting a human's health greatly. Surprising, right? The question is, however, can building shafts enhance urban street canyon passive ventilation? What if I told you it might actually be doable to do so? Now you may ask, why would we want to do that, and what good does it lead to? Imagine with me a hot air balloon. Have you ever wondered how it scientifically works? Well, what really happens is that the heater inside heats the air, causing it to move upwards, leaving the cold air down, and thus allowing the balloon to fly, serving people for both entertainment and transportation. And this, my friends, is an example of natural convection. In our project, we computationally studied natural convection of turbulent airflow in a vertical building shaft and explored its impact on the pollutants exposure and thermal comfort of pedestrians in urban areas. We basically took into consideration 4 different shaft geometries with varying outer cross-sectional areas and keeping the entrance size constant. For each design, we looked at heating the shaft walls at 3 different temperatures. The aim was to find a geometry that enhances wind flow in the building's surroundings. How? We basically found the ratio of mass flow rate induced by the walls and per 1 kilowatt of heat emitted by the shaft walls. Why? Well, improved air quality basically helps in reducing pollution, regulating temperatures, enhancing people's comfort, well-being, and favoring their outdoor activities over indoor. The aim was, in our research, we found that the building shaft with the biggest outer cross-sectional area had a ventilation effectiveness that is 2 times more larger than the shaft with the smallest area. This shows us that the more the diverging the walls are, the better the wind that is surrounding the buildings is. Now allow me to go back to my initial question. Can building shafts enhance urban street canyon passive ventilation? In fact, the answer is yes. With just a bit of knowledge on how to use the resources we have, we definitely can passively ventilate urban areas and hopefully upgrade pedestrians and residents' thermal comfort and well-being. Thank you.
Thank you very much. So Zainab, moving to our next speaker, who is going to be Joe Rahmi, towards wearable sleep apnea detection.
Hello, everyone. So before we start off with our talk, Well, you might be wondering, well, what am I looking at? That's basically me, and I'm doing one of my favorite things ever. And some of you guys' favorite thing as well, sleeping. Now, I know we don't get a lot of that at MSFEA, but let me tell you one thing. What if I told you that your crush, your professor, and TikTok Reels are not the only thing standing between you and a good night of sleep? There's a really undiagnosed syndrome called sleep apnea. And basically, if you were to Google it, it's just a cessation of breathing for at least 10 seconds. And it comes in two ways. There's the central one, where you're just not breathing at all during your sleep. And there's the obstructive one, where you're just choking because your upper airways collapse to the point where air will not flow through your lungs. Now, what if I told you that it affects about 15% of the world's population? And therefore, if you do not know anybody that has it, well, you might as well go ahead and check yourself. Now, here comes the second question. Well, how do I even check myself? Well, you're going to have to go to the bank and take a huge loan. And after that, you're going to go to a UBMC and do something called the polysomnography, which is a fancy term for saying that the doctor is going to attach 1 million wires all over your body from head to toe to study your brain, heart, and muscle activities. And I mean, who wants that? Really? Who wants to sleep and spend all that money during an economic crisis for them to have a bad night of sleep, when you could probably do it from the comfort of your favorite place ever, your bed? And really, this is something that our lab has been interested in. Really, we've been working on it. And only through PPG, which is the green light emitted by your smartwatch, which reflects your blood vessels dynamics, we are able not only to detect sleep apnea, but we're also able to classify it into central and obstructive. And that's very, very important, because for central apnea, you might have to take a couple pills, whereas for obstructive apnea, you might have to go to the gym and lose a couple pounds. All that is still taking a lot of time, and our lab is still working on it. And let me tell you one thing. We are working all night in this lab for you guys to sleep better at night. Thank you very much, guys. Vote for us, vote for us.
Thank you very much, Joe. So we're moving on to our next speaker, who's Mario Siedi, Robust Machine Learning.
The inability to predict outliers implies the inability to predict the course of history. That's a quote from Nassim Taleb, who got famous for predicting the 2008 global economic crisis. He was an options trader in Wall Street. Based on the predictions of his colleagues, they used models that basically were that, normally distributed or Gaussian. And from this point, he thought that they don't take into account extreme events like market crashes or bubble bursts. So these extreme events don't just happen in finance, they also happen in communications or in the medical field. So let me show you what we've been working on this past year. So we've developed machine learning algorithms that take into account these really extreme cases, okay, and we've compared them to the standard algorithms that we have today. So as you can see on the left-hand side, those are the standard regression and k-mean algorithms. And as we can see, for the regression, the predicted line is nowhere close to the actual line. And so if you were to buy a stock based on the prediction, you would lose a lot of money. And also in the standard k-means algorithm, it's nowhere close to clustering as it should be. Now in our robust implementation, as you can see here, we can't really know the predicted line from the actual line because they're exactly the same. And we have a better understanding of the clusters. So from here, we can say that thanks to my research, we are one step closer to being able to predict the future, or at least to be able to predict the future of the prices of stocks and make some money. So yeah, thank you for your time.
So moving on, so we only got 2 speakers left. Abdelkader Al-Hamwi, post-fire response of partially restrained connections.
So imagine a busy city skyline with tall steel buildings and a lot of energy. But what happened when a disaster strikes? Fire, one of the most critical challenges that can threaten the structural integrity of buildings, putting lives and property at risk. In this research, I've been looking what happened after fire, specifically how these connections perform. Are they significantly affected or not? So these connections are normally designed to resist load under normal conditions, but they face different challenges after facing fire. So after fire, not only the steel material will be weak, but in addition, additional forces will be applied on this connection, affecting their behavior. So under those conditions, they can significantly be affected. So based on this, a step-by-step design methodology is developed in order to investigate the post-fire response of those connections, taking into account those additional forces. From it, the remaining capacity of those connections can be determined. So based on this research indicate that the higher fire temperature that during a fire can be reached, the lower remaining capacity is achieved. So for example, steel connections can retain between 20 to 70% of their original capacity after being exposed to temperatures between 200 and 500 degrees. So what does this mean in real case scenarios? So after fire will take control over fire in steel buildings, is this building safe to be reused or no? So an engineer will come and assess this building, and based on the developed methodology, they will understand a clearer understanding on which connection may be reused or may be replaced or is safely or need reinforcement. Now let's consider another critical aspect, the financial aspect. So for insurance company, every penny counts. So after fire, insurance companies will hire an engineer to assess what is left from the building capacity. And based on it, they will only cover the percentage decrease of this building. So based on this methodology, they will directly calculate the percentage damage and accordingly cover the percentage decrease. So based on this methodology, safer buildings and safer assessment process can be used, saving a lot of lives and money. Thank you.
Okay, thank you, Abdul Qadir. So, lucky last, Doria Dubal with choreographing ground, a reconception of spatial dynamics. So, please come up, Doria.
What is ground? A simple question. Ground, we think of it as the static surface upon which we walk. But what if I told you that it's more than just a foundation, more than just a framework that does not evolve, that does not move? If you look at it from different perspectives, different disciplines, for example, from a philosophical one, ground is the dialectical relationship between different forces. These forces shape our surrounding, our universe. From a spatial construct, ground is the interconnection and the network and matrix of different people that interact together and shape their ground. It's the interconnection between people, users, and forces. Therefore, a keyword emerges here, which is a multi-layered entity. From this keyword, we arrive to the site that is Dali. Dali, if you look at it from the word, it's a vineyard. In Arabic, it means a vineyard. Vineyard is an entity that expands, moves along an axis, and changes with the temporality, with the seasonality of the sites. Dali as well, the multi-layered aspect of it. We have the land that interacts with the water that interacts with the wind, the tides that are ever changing, and the people that appropriate every inch of the site. Therefore, a new architecture emerges, which is a dynamic one that works as an entity, as an intervention that harvests the forces that are already at play at the site. These forces, the wind, the water, the fog. For example, one of the installations harvests the fog to create water. This water irrigates the site and thus enhancing the vegetation. Another one uses the power of wind, of energy, of sun in order for the architecture to move, to expand, to follow the topography of the sites. This architecture is not a static one, just as the ground is not static. It moves, it is temporal. It inflates, it deflates. It expands, it retracts. Every single movement is there in order to enhance the functions that we find there, to enhance the fishermen activity, to connect them to the water, to enhance the irrigation, to have a biodiversity in it, and most importantly, to create an architecture that connects different spatial dynamics together in order to choreograph the ground of Dali. Thank you.
Okay, thank you very much, Claudia. So we've reached our lucky last and finished our presentations, actually, I should say. So we've congratulate everyone. I think that's a good way to end, firstly. So, well done. I will mention, I mean, this is quite a competitive competition, and they were selected to be in the 3MT. So just getting in here is actually winning enough. So well done, guys. It's a very challenging... I'll test you guys to go home and try and talk about your research in 3 minutes. It's very, very difficult, so give it a go. So well done again. But now, while the judges collect their scores, we'll be announcing these awards, by the way, tomorrow at the awards ceremony, so please make sure all to be there. But now we're going to deal with the People's Choice Award. So you guys, all right, I hope you've all picked who your favourite is. Let me just get my system underway here. Okay. So you need to go to slido.com, just type that into your phones, and put in that event code, 6535228. So it's slido.com, put in the event code, and you'll have the list of speakers there. I'm going to bring this up. The code is still there at the top in case you need it. You have 12 speakers here, and I'm going to keep this open for just about a minute. The code's still up there. So judges, I'd prefer you don't vote. So yeah, we're starting to get people in. So please start voting as quick as possible, because I'm not going to keep this open for too long. Okay. 5, 4, 3, 2, 1. Well done, everyone. So I'll reveal what your choice was tomorrow. So congratulations again to all our speakers, and I will ask you all to come up so you can have a group photo together. And enjoy the rest of Ideas, guys. I hope to see you in all the sessions coming up in the next couple of days. Thank you.